Welcome back, everyone. In this part B of our lesson on markup, discount, and tax, we're going to be looking for some shortcuts that might help us to use problems a little less writing. Okay, so the question here asks, what percent could you use to find the final price after tax in one step? So let's assume there's a 7% tax. Okay, so to do this, let's actually go back to what we did at the end of part A of our lesson on markup, discount, and tax. Now let's look at some of the work we have here. So we had found that there was a $1.73 in a discount here. And what we had to do is, since it was a discount, we had to take it away from the original price to find our price after the discount. So this was our kind of money at the end that we were talking about. So we took the total money, took away the discount of the money, and we were left with the money after the discount. If I were to kind of make a connection from these three numbers to their percentages, 575 was our whole. It matched up with 100%. We can see that like over here. Here these two were matched up, right? Well, the 173, what does that kind of match up with? It is X, so it's matching up with our 30. So this is really 30%. This is the 30% that we're taking away. So if we took 575 and we took $1.73 away, we have our 402. Well, we started with 100%. We took away 30%. So what does the 402 represent? This really represents 70% of 575. 70% is what we'd have to pay after the discount. Let's look at a second example. If we then had this $4.02 and we wanted to add 7% tax, well, we went ahead and found that 28 cents was our 7% tax. And so here again, we dealt with money. We took our new whole, we added our tax to find our new price that we're going to pay. This $4.02 again was kind of our new 100%. What we were doing is we were adding 7%. And so what could we say that this $4.30 is equivalent to? Well, if we had 100, we're adding 7. We had 402, we added 28. So now we're really up to 107% of the original. And these numbers here can help us do this in a slightly quicker way than before. We can really cut out this step at the end where we have to add or subtract from our original to get our final answer. So, what percent could you use to find the final price after tax in one step? We could use 107%. Similarly, if we were talking about a discount of 20%, what percent would be used to find our final price in one step? Here, because a discount is something we're taking away, we would say that's 80%. Tax is added on, so we go 100 plus 7. But here we're taking away, so we do 100 minus 20 to get our 80. So let's look at a whole bunch of different situations with this. Let's look at a whole bunch where we have a discount. So if we have a discount, the discount percent is 10%. What percent are you then going to pay? Well, you're going to pay 100 minus your 10 to give you 90%. And if you had a 15% discount, take that away from 100, you're paying 85%. If it's a 65% discount, you're only paying 35%. A 30% discount, you're paying 70%. Okay, now what happens if, let's say that the original price of these items was $100? So if it was $100 and you're paying 90%, well, you're going to be paying $90. Well, how did we kind of come to that? We could kind of look at this as 100 multiplied by what? Not 90, but multiplied by 90 as a decimal, which would be 0.9. And 100 times 0.9 gives us our 90. Here, 100 times 0.85 will tell us that the final price of this item after a 15% discount would be $85. If we had a 65% discount, we would be only paying 35%. So we do 100 times 0.35 and realize that we're going to pay $35. Ooh, if we're paying X here? Well, notice where the 100 went. The 100 went here each time. So we've taken X, that's our price, and we're going to multiply it by our percent as a decimal, so 0.70. So what is X times 0.70? 0.7X. We can't obviously find out the answer without knowing the price, but we could write an expression for it, 0.7X. Okay, so that was all discounts, where we took a percentage away from 100. What happens if we're talking about markup? So if there's a markup of 10%, what percent are you paying? Well, you're doing 100 plus 10% to give us 110%. If it's a 15% markup, 100 plus 15 is 115. 100 plus 65 is 165. 100 plus 30 is 130. Okay, so now let's look at finding the final price if we had a $100 item. So if it was $100 and we multiplied, how do we turn this into a decimal? Again, remember the decimal, we can pretend it's here, and we move it once, twice over. So what's the decimal equivalent of 110%? 1.10. And we don't even need to write the 0. But 1.1 would be our percent equivalent, our decimal equivalent to 110%. And if we do that, we're going to move the decimal over a couple of times, and we get 110. Again, if the price is $100 and we're multiplying by 1.15, now we're going to get $115. All right, this time a 65% markup. 100 times 1.65. And that's going to give us $165. Oh, what happens if it's an X, an unknown price? X times 1.30 is going to give us 1.3x, just an expression to represent that. All right, let's do it again with a tax. So if we've got a tax, well, a tax of 10% is an amount that's added on to our original. So we start with 100%, we add on 10%, we have 110% that we're paying. If we have 7% tax, we're adding that to our 100 to get 107%. 6% tax. If you live in Beaver or Butler County, I believe they have a 6% tax. And if you have a 30% tax, 130%. All right, so if we go ahead and do the same thing, 100 times the decimal equivalent, 1.1, we're going to get $110. If we do 100 times 1.07, make sure you don't call that 1.7, we're going to get $107. And if we have $100 times 1.06, we'll get $106. So what happens if we have X times 1.30? Hopefully it's not something you just purchased at that kind of tax rate. That's a high one. All right, so 1.30 times X would just be 1.3X. Awesome. Okay, so we're going to use that to help ourselves solve some problems a little quicker. And let's actually apply this to a slightly more challenging problem here. So it says if Walmart purchases a DVD for $8 and then marks it up 100% and then discounts it 30%, and then the customer pays 7% sales tax, how much does the customer, what is the cost to the customer? Okay, so let's do this in steps. So if we set up our proportion, we know that we're starting out of 100%, but what's the markup price? What's the price percentage that we're going to pay? If it marked up 100%, we're going to take 100 added to 100 to say that we're going to pay 200% to start. The price was $8. We don't know the new price. All right, so let's do some simplifying. Let's make this 2 over 1. That'll make it a lot easier. And then if we do our cross products, we just get X equals 16. So $16 is the price after the 100% markup. All right, so now let's move on to the discount. So now we're still out of 100, and we actually know that our new whole is 16. But if we're doing a 30% discount, what amount are we paying? Well, we're paying 70%. So 70 out of 100 is going to be what out of 16? All right, so now we have to, we can simplify a little bit. We can make that 7 out of 10 if we wanted to. And then we can do our cross products here and get 10x equals 112. And divide by 10 to get that x is equal to $11 $1.20. Okay, so we're almost there. We've done the markup of 100%, the discount of 30%, and last we have to do the sales percent of 7%. All right, so again, we're out of 100. Our new whole is $11.20. What's going to be the percentage that we're going to pay after that tax? We're going to pay 107 because 7% is over that 100% that we're paying, and we're looking for X here. So 107 times 100 times X is 100X, and 107 times 1120 is 1,198. We divide both sides by 100, and we get that X is equal to $11.98. So the final price is $11.98. So by going to find directly the percents that we're going to pay at the end of each stage here, that saves us, if we go back to what we did last time, that saves us this stage of the game here, where we had to add or subtract to the whole. Each time, whatever comes out as X is going to be our answer for that stage. Now that number did carry across, so the 16 here did carry over to here, and the 1120 here did have to carry over to here. So there's still different stages because there was a markup, a discount, and a tax, but in between each stage we didn't have to add or subtract it from the original. All right, so let's look at one more challenge. This one says if Walmart purchases DVDs for X dollars and then marks them up by 100%, discounts them by 30%, and then the customer pays 7% sales tax, how much does the customer buy? So for this one, we're not going to be able to find an exact answer, but we're going to be able to write an expression for X. So let's go ahead and kind of set this up. The numbers are the same for the percentages as last time, so a lot of the setup here is going to be the same. So on the right hand side, X is our price, so that goes on the bottom because that's our current whole. We don't know what should go on the top, so we need to make up a new variable. Let's go with C for no good reason, and that'll be the cost after the markup. After the markup of 100%. So we do our cross products. 200x equals 100 to C, and then what we can do is we can divide both sides by 100, and we can see that 2x is equal to C. And so then we're going to take that and carry it to our next part of our proportion, so our next proportion. So we're going to go ahead and start out of 100, and we're going to go with 70%. And now this time, for our second fraction, we're going to put the 2x on the bottom, because that was our cost. That was really what came from the last problem. And we'll make up a new variable. Let's go with D, just to go in alphabetical order. All right, so we'll do our cross products. 140x from 70 times 2x is equal to 100D. And we'll divide by 100, and that'll make this 1.4x is equal to D. And so that's now the cost relative to having the markup and then the discount both applied. All right, so now the tax is 107% out of 100, and that's going to be equal to, let's call it E for something new, out of 1.4x. And we'll do our cross products once again, and this time 1.4 times 107 is going to give us, or 100e is equal to 149.8. And if we divide both sides by 100 here, or 149, then we will get that E is equal to 1.498x. And so what does that mean? Well, that's certainly our expression. 1.498x is the expression for what the new price is going to be. But another way to think about that is if we took our original price and we multiplied it by 1.498, that would give us our final price. That's kind of the effect that all of them together have on this. So 1.49x, or you could say it is 1.498 times the original cost. So let's go ahead and check that out for a second. If we apply this to our Part 6 problem, where the cost started at $8, and we multiply by 1.498, we would get that the price turns out to be $11.98. So that kind of confirms that our expression for number 7 works, even though I would not recommend that as the way to solve number 6. Number 7, definitely a more challenging problem beyond the scope of what you should expect on the test.